Okay, everyone, so I got a few questions about the PVT diagram and the constant line. This is something that in my Thermo 2 class I covered maybe like the third or fourth week of the semester, but it stays with you throughout all of Thermo 1 and all of Thermo 2. So because of this, I really need to make sure that you guys have a good grasp on how to navigate the PVT diagram and what the parts and pieces of it is. And then also, this is just kind of like a notice to everyone. If you have something that you don't understand or you don't quite understand, like the verbiage that is being used or why I'm calling something a certain thing, please reach out to me. I don't care if it was covered the first day of Thermo 1 and you feel like you should know it. I am not here to dictate or critique your Thermo 1 experience. I am here to make you successful for Thermo 2. And so if that means doing things like these little videos so that I can make sure that all of the students are on the same page with the foundational knowledge, then I can help to get you to the other side of this class a lot better, right? So I really appreciate the couple of students because there was multiple. There wasn't just one. There was multiple students that asked the same question. It was a really good one, so I'm really glad that you guys did ask these questions. So this PVT diagram, I know that everyone worked off of it. It is a three-dimensional diagram. So just like you've got, oh look, my writing board's upside down. Hang on. Let me turn it so that I can write correctly. So if you've got, this is really rough, but you've got 3 dimensions here versus just 2D here, with an X or a Y and an X axis. And then you have Y, X, and then a Z axis, right? So you have 3 different dimensions here. So that's the same way that it is here. We've got volume, we've got pressure, and we've got temperature. And it just happens to be laying this way, right? So you can rotate this way, and your Y can be here, your X can be here, and then your box can look something like this, and your Z can be going, well, it would still be, but it would be up here. Or you can turn it around, right? So you can flip it all. And that's why you can have a TV diagram or a PV diagram, right? Because this can rotate. At the point of these diagrams, let's see. So here, when we have any PV, we'll just say this one's a PV diagram, and we'll say that this one is a TV diagram, okay, right? So we can have either or. Within both of them, you see this bell curve right here, okay? So within both of them, we're going to have an expertly drawn bell curve, as you can see. So you'll have these bell curves here, and they will all have a lot of the same points. So you'll still have right here, it's noted as critical state here, but it's actually critical point is the correct terminology in your book. Also, this is in your book. I can get you the exact page if you need it to, but I thought it would be easier if I just explained it. And then here we've got kind of like an invisible line, right? And so you've got the liquid over here, see the liquid, and gas on the other side, so we'll just call this vapor. And then everything under here, everything under this bell curve, and it's the same for both sides, is a liquid and vapor region. And this is a 2-phase mixture. Everything under here, and you'll see at 2 p.m., so 2-phase mixture, which is a mixture of liquid and vapor, okay? And that's the same for here. Same thing underneath this curve. This is liquid. This is vapor. So other than the P or T, it's pretty much the same. We're going to treat it as the same. However, you will notice right here, you have two constant lines in here, and you only have two, okay? So you see we have two that we can hold constant. So that's why when anyone refers to the constant line in a PVT diagram, it can only ever be one of these two things: constant pressure line or constant temperature line. And because you see that on the left, this is a three-dimensional diagram, but on the right, we are definitely drawing it as 2D. How are we going to grab that third dimension, if you will, right? And so what it is when you have a PV diagram, your constant line is going to be T, because you're not going to have, let's see, you're not going to have an additional pressure. Let's use rainbow, because, you know, I'm just really feeling it. So let's just say that these are our constant lines, because you see that through this bell curve that we're working on, we've got a constant pressure line right here. It just goes straight across. And we've got a constant temperature line that goes straight across. So you see, that's why I'm drawing it straight across at just some random level, right? Not to scale. This is going to be, on a PV diagram, this is going to be a constant temperature line. On a TV diagram, this is going to be a constant P. And that's so that we can get a PVT diagram that represents this. So this right here and this right here is a two-dimensional version of this 3D over here. It's just that we are changing whether we have it on the PV version or the TV version, okay? But we still have to represent this other constant line, okay? And so within here, you'll see it drawn differently. I'm not going to draw it out here, but you'll see that this, let's see if I can, yeah, let me just get this off. That'll help. Okay, so see, for the constant temperature line here, it goes through when you have a PV and you have a constant temperature coming through, PV constant temperature, it's coming through here and it's going down and it's going up, okay? So that's how that is going. But if you see that it's almost opposite, and again, we can't look at it from this PV here and plot the constant pressure line and convert this easily to a TV. We have to change it, and we have to put this T on this side and keep the V. So we have to turn it like this. This is your starting point. Picture you're holding this cube and you are turning it, right? That's how we would have to get it. And you're essentially looking at it from this point of view, from the back, which then becomes the front. And you see that that constant pressure line is actually flipped. So that's why sometimes you'll see them like this or whatever. Actually, let me pause it and see if I can just grab that. Okay, so you see here, we've got, let me see if I can, let me just move this over. Okay, so you see here, we've got a TV version of it, and you see that we've got the constant pressure line P, and it goes up. So depending on how you rotate, and this is something that I'm not, you're going to have this information. So I'm not going to say, hey, you know, which way should your lines be pointing? You know what I mean? They're almost 90% of the way pointing like this. But that's something that you're not really going to have to concentrate on. But I just wanted you to know that, see, when you have a TV diagram, that all of this stuff is going to say we've got that two-phase mixture, we've got compressed liquid, we've got superheated region, we've got a critical point, and then here this constant line is a constant line of pressure, okay? And why is it constant line of pressure? Because we have T and V represented here, and it's a PVT diagram. It's for all of them. So let's just walk through, how we would work it. If we start here, okay, and we're increasing in temperature, say we're increasing in temperature and increasing in V, right? So how we would get there is we would continue on this pressure line. And so say then, this was state 1 and say this was state 2. Well, at state 1, we would have a T and a V and a P, okay? And so then when we go to state 2, we would have an increased T, an increased V, but P would be constant, right? Because we're on a constant line. And then when we're heading through this two-phase mixture, let's say at 3, we're right here, okay? Your T and P would be constant, but your V would increase. And then say our 4 was in the superheated vapor region, and at state 4, we would continue up. And so then we would have, again, an increased T and an increased V, and then our P would stay the same. So this is kind of like, if you think you're a little car, you know what I mean? Like you can cover a lot of mileage and it can take a lot of time, but you're staying on one constant road. You're never leaving it. That's how you move within this PVT. So I hope that helps.